Welcome back. In this business finance lecture, we'll go over study problem 10-6 in page 336 from the 8th edition of our textbook. Here's a view of the problem. Let's first highlight the key ingredients in the problem. So, we are being told about two separate projects, A and B, and these projects require separate initial outlays and their cash flows are also different. However, both project has a 6-year lifetime. The required rate of return for both projects is 12%. So, given these figures, using the usual methods of NPV, PI, and IRR, compute these numbers and then decide whether the project should be accepted or not. So I will not go over the displays of your calculator and what keys that you need to strike into your calculator. That should be pretty straightforward. All you do is you make sure you have your initial outlay clearly written, and then because the stream of payments are even amounts, it should make your life very easy, and you should enter CF0 as 6. So having done that, the NPV of the first project, so what I will do, you can solve parts A and B actually, and B at the same time. What I will do for that is I will create a table that would represent, the first column would represent project A, the second one is project B, the first line would represent the net present value for project A, and the second line would represent the IRR for project A and B as well. So, having said that, assuming you will enter the correct figures, the NPV should come out as $668 for project A, but with a negative sign, unfortunately. So, minus $668. Whereas the same figure for project B is even worse, minus 17,000. My apologies. So minus 16,550. So let me make this correction quickly here. Minus $16,557. Regarding the IRR, the first project, again using the second row of your financial calculator, you should realize that the first project has an IRR of 11.53%, where project B has even worse, 3.18%. Now, looking at this table, I can realize that because both NPV entries are negative, both projects should be rejected based on the NPV approach. But even when you look at the IRR, the result will not change, obviously. Both projects should be rejected because these projects provide a lower required rate of return than the required rate of return. So these in nature, these methods agree on their results. Finally, you can also go ahead and calculate the PI. That would be part B. My apologies, previously it was part C. Okay, so for part B, the PI, recall that the PI was just adding the net present value to the initial outlay. In this, for the first project, for example, you would add minus 668 plus the $50,000, all divided by $50,000, and so that would be for project A, and project A would have a PI value of 0.9866, decidedly less than 1, so this project should not be accepted. And similarly, using a similar methodology, you calculate PI for the second project. It gets even worse, 0.7635, and again this project needs to be rejected. So both projects has to be rejected based on all three methodologies that we are employing. Now, what's funny about this problem is the fact that both projects provide an even stream of income, and as such, it is possible to calculate both the NPV and the IRR without resorting to the cash flow keys on your calculator, but rather using the third row of your calculator. So I will go ahead and show you how you could have alternatively solved this problem. So a second solution for NPV and IRR. So let's begin with IRR first. So I'm considering the first project. We have N, I over Y, PV, payment, and FV keys. Obviously both projects are sold at salvage value. The first project has a $50,000 initial outlay. Don't forget to put the minus sign, and the payments over the next 6 years are expected to be $12,000 over the next 6 years. You press here for the question mark and you compute I over Y. Quite strikingly, it will give you the same IRR result that you got earlier. So that would be the IRR of the first project. For the second project, things will not be any different. So N, I over Y, PV, payment, and FV. Again, F, that's an F. That's a 0 here. The second project is expected to have $13,000 returns. However, you need to make a significantly larger initial outlay to get this, and those are the remaining parameters given in the problem. You compute I over Y and it comes out as 3.18% as previously. So that would be the IRR of project B. So that's very efficient way to calculate the IRR if the cash flows, like in this problem, are even, meaning you have a constant stream of payments. In a similar fashion, you could have calculated the present value. So let me go ahead and create a new page and show you the solution for in the case of net present value using your calculator again. So second solution for NPV. So all we do is, for the first project again, we use N, I over Y, PV, payment, and FV keys. Now the question mark is in the present value. Now the payments are no different, still $12,000. The project has 0 salvage value. It's a 6-year project. However, the required rate of return on this project is 12. So from here you can go ahead and compute PV, and you should get $49,332. $49,332. Now, in order to get the NPV, what we need to do is we need to subtract the initial outlay from the present value calculation. So the present value was $49,332. We subtract the initial outlay of $50,000, and lo and behold, we get the same result of minus $668. You could have employed a similar method for the second project as well. It is the same method, so you can do it on your own and see if you can get the same result as well. So that concludes our solution. Hope you enjoyed the video. See you soon.